Welcome, Hornets. In this video, we're going to be taking a look at the last two of our transcendental functions, specifically the derivative d dx of the secant, and then we're going to take a look at d dx of the cosecant, or the derivative of the cosecant. Now, as we did before, we're going to change this into its ratio. This is the reciprocal function, 1 over cosine of x, and it is now a quotient, so I can work with f prime g minus f g prime all over g squared. The derivative of 1 is 0, so we're looking at 0 times cosine of x minus the negative sine of x all over the cosine of x squared. Now that's going to go away, so we're looking at positive, sine x, cosine x, and I'm writing it this way so that I can now rewrite it as the secant, 1 over cosine, times the tangent, sine over cosine. And that's what we're looking for, secant x, tangent x. We're now going to put that right up here, secant x, tangent x. And this is our rule. Questions? Obviously none. Let's take a look at our next one. The last one that we have is d dx of our cosecant. As we did before, we're going to change this into the reciprocal function, which will give us the ratio and therefore a quotient. Once again, we have our low d high less high d low, square the bottom, and away we go. We know that 1 is 0, the derivative of sine is cosine, so we have 0 times sine minus cosine x times 1 divided by sine squared x. Just as we saw before, this piece goes away. Now I have a negative, which I'm going to pull out in front. I have cosine x. I have sine x times sine x. And you'll notice there's a cotangent in here. So we're looking at 1 over the sine of x times the cosine of x over the sine of x. And this gives us negative cosecant x, cotangent x. And that's our answer. That's what we're going to put right up here. Negative cosecant x, cotangent x. What's interesting is that all of the transcendental functions that started with a c were negative. The cosecant, the cosine, and the cotangent. Alrighty. Thank you very much, Hornets. I hope that the derivations made sense the way that I was working with them. And if you still have questions, please always remember you should come into my office hours. Thank you very much.